Regardless of what type of data we're looking at, a GIS has two different ways of storing. It actually will store your data using two different functions. Right? That first one is going to be a spatial representation. It's going to be something that we can see on a map. It's going to be location based. But behind all of the data that we look at in our GIS, there's always going to be a table that is associated with that. So if we even think about the term geographic information system, the geographic refers to a spatial representation, a map. And the information system refers to a table. So at its very core, this is it. The idea that a GIS is going to be storing data as a location and as a table of attributes. Now, if you'll notice in the background there, we have some soil data. It's for the community of Buellton in Santa Barbara County. And then we have this attribute table. It's so much more than just that map because there's a lot of information that's stored about that area. You'll notice that in that map in the background, there's that area that's highlighted in blue. Well, on the table, it's also highlighted in blue. And there's always information about those locations that's going to be stored in that table. Now here we just see the coding that's used there, but in this particular table, it goes through and it says, for example, in that last column, that it's prime farmland if it's irrigated. And so there's so much information that can be stored about a location. And with a spatial representation, we can get both of those combined. That's the great big idea of GIS. So let's talk a little bit about this data creation. In a GIS system, you will have the graphical interface. It'll be Windows-based usually, right? You're going to have the buttons and the bells and the whistles and everything else like that. Some functionality that you're able to do. One of those functions that you're able to do is to create new data. I've done this plenty of times where I have had an image. Maybe I'm looking at an image of a topographic map or an image of a different type of map, or I'm looking at aerial imagery that was taken from an airplane. And I want to create road data based on that. And so I will just take a look at that road and click, 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 create new features based on that. Now, what I can also do is I can extract information from a table. So, for example, let's say that I have a layer of road data, and it's got all of the roads in the entire county, but I only really care about the highways. So within that table, there will be a coded value for all of the roads, the general roads, that are categorized as highways. I can select those and extract those out. So we can create new data from scratch, or we can sort of extract, or we can combine data sets even to get some of that out. In the GIS, we always have those tables, and certainly we can populate those tables. We can edit data. We can move around the geographic features, but we can also manipulate the data tables. There's other ways that we can take and manipulate that data by creating graphs, graphical representation with our maps as well. And that brings us to those next 3 points, right? We can create we can create maps. We lay out the maps with a title and the scale bar, with the legend and the neat line and the north arrow. We can take all of the different data layers that have been created and combine them together to make a map. Now you can also present tables, you can present graphs, and there is some printing and exporting functionality that's available in these GIS systems, or in the computer-based interface that are there. Now, I do want to talk about the spatial analysis, and I always like to bring up this guy right here. His name was John Snow, and he was an anesthesiologist of all things in London back in the 1800s. In 1854, there was a large cholera outbreak, and cholera was a disease that wasn't very well understood. They thought at first that it was transferred by air molecules. That it was transferred through the air, that it was an airborne disease. Well, John Snow wanted to understand this disease a little bit better, and so what he did is he went through London and he made this beautiful map. Now, this map is very famous amongst us geographers because he was one of the first medical geographers looking at a problem based on that. And by looking at this map, he was able to start to come to some conclusions. he started to see some clusters. He started to see some patterns. And one of the big patterns that he noticed was right around this pump. If you notice this water pump, a lot of people died right around that water pump. Okay. Now, there were certainly some other places where people died. Every line, by the way, represents someone who died at that particular residence. Okay. So some people died here, some people died up over here, but all of these places are kind of clustered right around this one water pump. Okay. There were a few people, a few outliers there. He went and found out from this household, for example, that they much preferred the water that came out of the Broad Street pump rather than the pump that might have been a little bit closer. So with all of this information, he was able to go through and look at the information based on location. He's able to do some spatial analysis with that. So asking questions based on location. Now, we can do that as well in a GIS. All of the data is represented in real-world coordinates and real-world distances. And so you're able to go through and you're able to ask specific questions. How far is it from my house to the nearest fire hydrant? Where is the closest Starbucks to where I'm located? What is it within 300 feet of this construction area that we're going to be building? Where can I find farms that are available for sale and prime soil? Okay. What is the area of these 3 parcels? So all of this information can be acquired inside a GIS. We can start to ask those questions. Some of these questions are going to be pretty basic. Some of them is where we start to combine information from multiple data sources. That one example, the second bullet up, where farmland and farms that are available for sale and prime soil. Well, what we would need to do is have a layer of all of the land that was available for sale. And we would need to have all of our soil data available. And if we combined both of those, then we'd be able to find out where those things are. Now, there are a broad range of users for GIS. There are countless ways that the GIS is being used. I hope that as you go through the rest of these presentations, as you learn more about GIS, that you'll understand more about who the people are that are using it and how it is being used.